Welcome to Lesson 2, Cloud-Based AI Labs and Sandboxes. We start with a discussion about the advantages and disadvantages of cloud AI labs and sandbox environments. We will explore Amazon Bedrock, Amazon SageMaker, Google Vertex, and Microsoft Azure AI Studio. We will then finish with a discussion about cost management and security. Cloud-based labs or setups or sandboxes definitely can leverage many different third-party platforms that are so popular out there, like AWS, Google Cloud, and Azure. In the case of AWS, we already mentioned that they have things like Bedrock, SageMaker, and many other machine learning platforms that are available to anybody in the industry. Google Cloud, they have Google Vertex AI, which also allows you to deploy many different models, fine-tune models, and even train models from scratch and so on. Azure is another alternative, and of course they have Azure AI Studio. And at the end of the day, all of these are competing against each other, so they basically provide very similar functionality. So let's go over some of the advantages and the challenges of deploying a cloud-based AI lab or a sandbox. The first advantage is scalability. Resources can be scaled up or down on demand to meet your workload requirements. The other thing is that you have the pay-as-you-go pricing, and it eliminates upfront hardware cost, and you only have to pay for what you use. So in some cases, people go overboard at home and they buy too many PCs and too many, hardware components. And I'm pointing fingers to myself because I do that all the time. And in that case, I barely use some components that I buy, and some other ones that actually I do use it every day, right? So in this case, the cloud allows you to pay as you go, and then you only pay for what you use. The other thing is that we're going to talk about the challenges. Is one of them is cost as well, because it can also bite you at the end of the day. So if you have a pretty comprehensive environment in a cloud environment, whether it's AWS, Google Cloud, or Azure, they're not cheap, right? Now, teams can also collaborate remotely from anywhere. So if you're doing this for your team at work, then you can do a lot of collaboration because everything is in the cloud, right? The other thing is providers offer pre-configured environments with very cutting-edge tools with generative AI implementations, Jupyter notebooks, many different large language models that you can choose from, and methods for evaluating your application, and many things that you don't have to actually deploy from scratch. Now, if you're learning, one of the cool things to do at home is actually to deploy some of these libraries, from scratch. We're gonna go over things like LangChain, LangGraph, many other libraries for orchestration and for you to create agents. And definitely you can deploy that at home with Olama running different models, and you can practice your skills and upskill yourself, and of course be able to learn these cutting edge tools and libraries and implementations. But of course the cloud provide a lot of pre-configured environments and a lot of ways that you can just very easily just spin up a VM or deploy different containers in a very, very, very fast pace for you to experiment and to play with large language models, right? The other thing is the infrastructure, as far as the hardware management, is all handled by the cloud providers. You don't have to worry about that, right? And they are updating their hardware. And in your case, you will have to actually upgrade your system, your server, your PC, and so on. But there are definitely a lot of challenges. One of them is a data privacy concern. Now, a lot of cloud providers, they're actually very trustworthy, including AWS, Google Cloud, all the ones that I'm been mentioning, of course, are the major ones. But a lot of organizations, especially whenever it comes to AI, they are very concerned of their data being exposed to an AI model or an AI model provider for them to actually use that data for training. Many providers nowadays, including AWS, Google Cloud, and Azure, they actually have contractual agreements with enterprises on where they guarantee that none of the data will be used for training any type of AI model. And that's actually something that is extremely popular in the market nowadays, is actually having those contractual agreements with their providers to make sure that the data is not being exposed, right? Another challenge is vendor lock-in. In other words, switching to another provider can be difficult because of some type of proprietary tools or different configurations. And of course, at the end of the day, a lot of overhead for you to actually switch between the providers. Nowadays, it's a lot easier. We're living for the longest time in a multi-cloud environment, but there's still a little bit of a challenging if you want to actually switch providers in some cases. The other thing is the performance will rely on a stable connectivity, so latency can affect real-time application, especially if you're thinking about doing somewhat of a hybrid approach between a home-based or an on-premise lab and a cloud-based lab as well. The other thing is that even though they provide a lot of pre-configured environments, there's limited customization. So cloud solutions may not offer the same level of configuration options that you have, of course, at home. So budget, data sensitivity, scalability, and even expertise. You need to be skilled, and you may prefer home-based labs for a little bit greater control because you may not be familiar with a lot of cloud-based implementations like AWS and Bedrock and so on. And some of them that can be a little bit convoluted as well. But this is my recommendation. I always recommend for you to do both. Especially, we're talking about here learning, building labs for you to learn the technologies and the different libraries, surrounding libraries that make up an AI application. So whether you're using something like LangChain, Llama Index, and so on, of course you can deploy that whether it's in the cloud or on-premise. But for learning, it will be amazing if you can learn all three cloud providers. So AWS, and I'm generalizing in the top three, of course, the most popular ones, but Google Vertex or AI Studio in Azure or Bedrock or SageMaker, having exposure to all these environments will definitely make you a lot more marketable, and it will actually increase your knowledge, in all those platforms, right? So again, it's a personal decision, but I always recommend for you to actually do both. Deploy things on premise and your home, and also, even if it costs a little bit of money, deploy a few things in these providers. Let's go over Amazon Bedrock or AWS generative AI platform. Bedrock is a fully managed service by, of course, AWS and Amazon that allows you to deploy different types of AI models and features to accelerate your business workflows, and of course, for you to deploy different AI implementations. A few of the key features of Amazon Bedrock is that it offers a curated list of models that you can use, foundation models from top AI organizations, including Anthropic, Cohere, Stability AI, Meta, and many others, right? So even, of course, Amazon's own models. These models are, of course, the pre-trained on extensive datasets, allowing you to perform different tasks, and you can combine these with other implementations in an on-premise lab to then, experiment and of course, become familiar with these technologies, right? You can come to this section here, the custom models and fine tuning, and allows you to, of course, to fine tune different models and create your own domain specific model. Or you can also generate synthetic data from a large foundation model, basically using that as a federated learning environment where you can use a model for, I'm going to put here M1 for the first model, to then generate synthetic data to train a new model. I'm going to call it X in the screen here, right? So that's what the distillation techniques and functionality in Bedrock, as well as other cloud platforms, they have similar, methodologies and similar features. You can, of course, do this on premise. However, the compute power for some of these may take a significant investment. So that's where you playing with these cloud platforms, it makes it a little bit more budget friendly instead of you having a bank of GPUs in your environment. The other cool thing that Bedrock actually has is that you have a playground, just like the playgrounds that we were covering earlier with different implementations, including Rackflow and some other ones. But this is basically included within the environment, and you have a single prompt to generate single responses or generate a conversation and intervally submitting prompts and replies to see his response so you can evaluate your custom application. It also allows you to create agents. So if you navigate to the agents section in here, you can create an AI agent very quickly. I'm just going to put here Omar test agent 1. And then, of course, you can put a description and even enable a multi-agent collaboration. So basically, if you have more than one agent, they can collaborate and interact with each other. And then once you click on create, it will take you to this screen where you can select specific models. By default, I had Claude 3.5 Sonnet because I already had deployed it in here. But again, you can use a specific service role, create a new one, select one from the pull-down menu. I don't have anything created right now. And then you can give a specific instructions for the agent. So basically system prompts and personas, and then associate this with other functionality, including code interpreter, even selecting whether the agent can prompt for additional information from the user and so on, as well as how to perform encryption in your datasets, right? Even customize encryption settings and many enterprise grade functionality and applications, because at the end of the day, this is, of course, being tailored for very large organizations to be able to take advantage of agentic implementations and so on. You can attach new knowledge bases, that you may actually have, or add a new one as easy as this, right? You can basically create a new knowledge base and attach that, proprietary content for you to allow the AI environment or the AI agent to provide additional context that is relevant for the domain-specific task that you want to give it. Another feature that you have is the flows feature. And flows is basically the ability for you to create a sequence of events that will correspond to invoking actions in Bedrock, and then attach knowledge bases, invoking a new or existing AWS Lambda function, and then calling Amazon Lexbot for you to interact with these applications to, of course, take your deployment to the next level. So one of my recommendations, if you're setting up an experimentation lab, I will say that start with just a simple, deployment of a model here. See how you can incorporate your knowledge bases, even if it's something that you create by copy and pasting a few, documents out there, but at least for you to get familiarized with the retrieval methods, all the different types of RAG implementations or retrieval augmented generation, and then take it to the next level into building agents, is creating creative system prompts, working on your prompt engineering tasks and so on. And then, of course, going to the more advanced sections. But this is something that Amazon is evolving almost on a weekly basis. You see a new feature here. So again, some of these will cost money, right? Especially if you start deploying different Lambda functions, if you start playing with different data sets that will require storage and so on. But for quick labs and for learning, it is very, very minimal cost, and you can, enhance your career and enhance your skills by just playing with these feature sets in here and understanding the end-to-end generative AI workflows that exist within these cloud platforms. Let's go over Amazon SageMaker, which is basically a sister tool, if you will, or an ecosystem to Bedrock, which we just reviewed, right? So SageMaker is a fully managed service from AWS that is designed to streamline the process of building, training, and deploying machine learning models. This also allows you to deploy traditional machine learning as well as interacting with different generative AI and newer, transformer-based models as well. It has a very comprehensive set of tools and infrastructure, and as a matter of fact, what they do is they integrate a lot of the existing, very popular applications like Jupyter Labs, RStudio. They have their own canvas. They have their own code editor with a lot of additional machine learning open source frameworks like MLflow as well. So SageMaker basically is empowering data scientists and developers for accelerating their machine learning lifecycle, including these environments, right? So you have a fully managed machine learning workflow that handles all the operational aspects of machine learning development, allowing you to focus on model building rather than the infrastructure management. But one of the things that I want to highlight in here is that as soon as you're actually starting to deploy some of these features, it's also interacting with other areas of AWS. Like, for example, different artifacts from experimentation and pipelines and so on, starting to instantiate different S3 buckets, EC2 instances, and so on. So you have to pay attention to the usage and, of course, the cost in here. So from a lab perspective, it is really important for you to experiment with all these platforms, right? I will not call them new platforms because SageMaker has been in existence for quite some time, but also pay attention to cost. This training is focused on generative AI applications. So I'm going to be very high level here whenever I go over the applications and the features of SageMaker, but I'm going to highlight a few things in here. So the first one, of course, you can instantiate a Jupyter Lab. You can see the different Jupyter Lab spaces. I already have one in there called test 1, 2, 3. And right now it is running on an EC2 instance. Just like I mentioned to you earlier, right? You have to pay attention to the costing here, but it's running in an EC2 instance that is the default one, that is machine learning or ML.T3 medium. And I think that it has 4 gigs of RAM and 4 virtual CPUs, right? And then you can have different image. I just selected the default one in there. I'm not going to change it in this case. And then you can launch a Jupyter Lab, right? You can open Jupyter Lab in here in a different instance, and it's completely managed. Of course, you can deploy Jupyter Lab on premise, and you don't have to pay attention to cost and and different environments here in AWS. However, this makes it so easy. With a click of a button here, I have access to many different types of implementation, including PySpark, GlueSpark, a lot of Python sample notebooks, and many other capabilities in here as well. Now let's go back to the Amazon SageMaker Studio page in here. Another thing that I want to highlight, of course, you can have different compute pods and create many different pods for machine learning workflows to choose from different built-in algorithms optimized for different tasks or bring your own custom algorithms, package as Docker containers as well. And all that is definitely a feature of your environment here. And of course, bring your data sets. And Data Wrangler is a feature that allows you to prepare and do a lot of feature engineering and create different data flows to define a series of machine learning data preparation tasks and data preparation steps. So you can use a flow to combine data sets from different data sources. And as a matter of fact, let me actually open this in Canvas, and it will take a couple of seconds in here. There you go. And you can see, let me make this a little bit bigger, that you can import from tabular or CSV type of files, or even images for image classification and so on, right? You can also have different, or take advantage of different data sets. One of the things that I always highlight, if you're actually just getting started with machine learning, and of course with the AI, is for you to take advantage of publicly available data sets for your experimentations, instead of using very sensitive data from either your company or your own data, right? And they provide different CSV files in here, or data, samples of data sets that you can implement for or for your learning, right? And then use that for learn how to train a machine learning model. You can also use SageMaker Canvas ready-to-use models to make predictions on your data without writing a single line of code or having to build a model, right? So in this section here, you can click on the ready-to-use, which is what I am already in, and then you can select from different types of models and tasks like document queries and so on. And you see examples of document queries. This looks like a check. And of course, this is sample data and fictitious data for you to train your own model, or actually these are for readily accessible or ready to use models that allows you to interact with this type of data, right? So in this case, for financial applications, let's say you want to recognize different structures of financial documents, whether it's a pay stub, a check like this, and so on. It allows you to do that in a very comprehensive manner. Now, if you click here in the generative AI, let me make this a little bit bigger or smaller for you to read the generative AI. So if you click on that, you can access different foundation models that are available, and also implement different retrieval augmented generation environments, including Amazon's Kendra, which is a vector database implementation in here, right? If you click on Get Started, it allows you to navigate different foundation models, of course, including Titans models from Amazon, models from Cohere, of course, Llama, and these ones are older versions of Llama, but you can search from many others and integrate a few of them from Hugging Face as well, right? Now, Kendra is a very powerful vector database that it comes built in within the environment here. But I'm going to be very brief in this example, because I want to go back to the SageMaker main dashboard, the studio in here, right? And one of the things that I would love to show you is this thing called AutoML. And AutoML is basically an autopilot for training and fine-tuning AI models, right? And if you see here, I don't have any new models, so I'm going to just create one, Omar Model 1. And now I can select from the different data sets. I'm going to select the data set from there just for very brief demonstration. And then from there, you see that it has a lot of the data preparation already done for me. Of course, I just randomly selected one data set in there without actually looking at the details. But yeah, this is a sample diabetic readmission data set that they actually had, right? So I can use data visualization to look at specific columns in here. I'm just going to go drag and drop some random, data elements. and then use this data for building specific algorithms that are tailored to the analysis of, in this case, tabular data, right? So tabular data, of course, is any data sets that are organized in tables consisting of rows or observations and columns, what in machine learning we call features, right? And you have many different types of algorithms that are built in within SageMakers for tabular data and for image recognition as well. Those includes things like the traditional k-nearest neighbor factorization machine learning algorithms, light GMM, and the list goes on and on, right? So we're not going to go into the details of that in this course. But if you go back to SageMaker Studio, the main page in here, you also have the ability for you to create your own experiments. And these are different MLflow experiments. And MLflow is an open source platform that is designed for you to manage different machine learning lifecycle elements, and now is fully integrated within Amazon SageMaker. And this integration will definitely simplify the process of either tracking, managing, deploying different experiments within the ecosystem in here. And of course, not only the experience, but your models as you're training them, as you're deploying them as well. And I'm talking about both traditional machine learning models and also more modern implementations as well. Now, within the environment, you see this thing called MLflow Tracking Server. And Tracking Server is a fully managed MLflow deployment for, in this case, for you to eliminate the need to set up and maintain your own servers. But this server is where you will store metadata like parameters, metrics, artifacts for each of your training runs in a backend data store hosted within the SageMaker service. Basically, these artifacts are stored in a S3 bucket, in an Amazon S3 bucket within your environment and your AWS account. So again, as soon as you actually start clicking on creating experiments and so on, there are a lot of additional components that are being instantiated within AWS. So you have to make sure that you keep track of your usage and, of course, your cost. Even if you were thinking about doing this in your company or in your home, this will take some significant amount of preparation and, of course, compute power and so on. And that's what SageMaker, brings into the table, is the ability for you to do this with just a few clicks and then deploy some proven technology, including things like MLflow, to do experimentation and analysis of your workflows. But as I mentioned to you, this training is focused on you to build labs for generative AI applications. So I'm going to be very brief in here whenever it comes to SageMaker Studio, but I wanted for you to get at least familiarized with some of the capabilities that are within SageMaker and the environment. And as I mentioned to you earlier, one of the things that I always recommend to people is to practice. Machine learning, cybersecurity, AI is all like math. The more that you practice, the better that you will become. Google Vertex AI is a unified machine learning platform that is offered by Google. Very similar, and in some cases even more powerful, and in some other cases, is complementary than the other cloud platforms that you saw from AWS. So it does have a lot of features, from data preparation and model training to the deployment and monitoring of foundation models that you can select from the model garden in here. So if you navigate to model garden, you will see dozens and dozens of different types of foundation models, including from Anthropic, Meta, the thousands of models in Hugging Face, Mistral, and many others, right? So it is a unified platform. Instead of AWS that you had SageMaker and Bedrock, this one, all the tools that are needed for machine learning, you can use them in this main dashboard in here. in my opinion, this simplifies a lot of the task whenever it comes to creating or fine-tuning models, right? So you can use features from AutoML that you can train models for tabular, image, text, or video without writing any code, similar to what you saw in SageMaker from AWS. For advanced users, also Vertex supports different custom training capabilities using popular machine learning frameworks like TensorFlow, PyTorch, and they have a capability for you to write your own training code, your fine-tuned hyperparameter configurations with capabilities within the environment here. One is actually called Vertex Visor, but we're gonna go over a few high-level interactions with generative AI, pipelines and implementations in here, since this training is focused on modern implementations of generative AI. So if I go back to the main dashboard here, you see that they have different types of implementations, including a Google Colab Enterprise offering. So basically running your own Jupyter notebooks, in a hosted environment and so on. There are a lot of developer tools as well. So you have an SDK, so the Vertex AI SDK, which is a pretty comprehensive set of classes in Python that lets you automate a lot of the machine learning workflows and the generative AI implementations as well. You also can take advantage of Vertex AI Workbench, which is a Jupyter Notebook-based development environment that data scientists actually can use for their own entire workflow. And you can have information related to or have capabilities that can allow you to store and manage training datasets, just like you're seeing here. Very, very simple by creating new datasets, whether it's single label classification, multi-level, object detection for visual type of trainings, right? So image, tabular, text, and video as well. So if you navigate to the Workbench section in here, basically this is what I was talking about, an environment that is based on a Jupyter Notebook deployment for your entire data science workflows. You can interact with Google Cloud services and instantiate new environments like you're seeing here. You can put a new instance, attach NVIDIA GPUs, and so on. And then, of course, you have to pay attention to the costing here. But you can select from many different advanced options, including your environment, the type of the version of Jupyter Lab that you want to include, using custom containers if you want, and also including a specific metadata that you can add to your environment as well. So all these instance types are prepackaged with these Jupyter Lab environments and have a pre-installed suite of deep learning packages, including support for TensorFlow, PyTorch frameworks, and so on. You can use CPU only or GPU-based instances as well. Of course, you have to pay attention to the cost if you want to experiment with some of them as well. So I'm going to cancel that for a second. Then I'm going to go back to the main dashboard here. Now, the next section that I want to cover is Vertex AI Studio, and specifically this one is the Google Cloud Console tool for rapidly prototyping and testing generative AI models. And this is how you can use models like, of course, Gemini from Google and many others for prompt engineering, as you're seeing here, from prompt management, fine-tuning a model for being more domain-specific, evaluating, and many other types of tasks that you can incorporate in here. Now, Vertex AI Studio supports certain third-party models that are offered on Google Vertex AI as a model as a service. This is actually a new concept that you are hearing nowadays called MaaS. So AI model as a service. In other ways, for you to use third-party modules like Anthropic Claude models, Meta Llama models, and many others. The cool thing about this is that it allows you to either navigate through different prompt galleries and seeing some examples of system prompt instructions and so on, and then you can change for your own implementation. So I've just selected a random one in there called Buzz Juice. Is the only energy drink for all organic ingredients. So you can actually get a little bit information here about the brand, the campaign goals. So this one is actually specifically for an advertising campaign. But at any rate, you can select different models. So in this case, you of course you have the Gemini models from Google, and you can also integrate other ones through third-party implementations. And you can navigate many of them in the Google Model Garden within the infrastructure in here, right? So you have Anthropic, Meta models, Palm, and so on. Palm, of course, are the older models, and there are a lot of additional new capabilities. You can even include information for grounding or for retrieval augmented generation to then get source information from Google search, right, within your environment, right? And this is with very low code. As you can see, I'm just clicking on a few buttons, and if you click on get code, you basically get all the different elements on how to interact with the environment here in Python, or the examples of in curl, right? So you have to, of course, enable the API for you to interact with the environment in here, but it simplifies the task significantly for you. You can also use multimodal. You can have images and additional, information that you can put for the model, for the AI implementation to take advantage of as context, additional context for your either agent or your chatbot. So under prompt management, let me actually click in here to exit. You can create your own custom prompts, right? Either freeform, chat, translation, and so on. So if I click on chatting here, it takes you to the same page that we were earlier. And you can try even the multimodal element, which will allow you to use your camera and your microphone and so on. So I'm going to click on no for now. But yes, you actually have the ability to do vision, to take advantage of their translation capabilities that they have in here with multiple languages, and then also text-to-speech and speech-to-text recognition as well. You can upload different WAV files or record your voice, and then have that as a multilingual automated, speech recognition environment, right? The other cool thing that you can do here is to fine-tune different models. So you can select your environment in here. I'm in the East Coast, so I'm in Raleigh, North Carolina, so probably either South Carolina or Northern Virginia for me are the closest. And then from there, I can start creating a fine-tuned model, and I can name it, anything that I want, and select a base model. So I'm just leaving the default there of Gemini 1.5, and then you have different advanced options. I am not going to go over a lot of the elements of fine-tuning here, just showing you that you have the capabilities of doing fine-tuning in a pretty comprehensive manner in here. You can also associate this to a service account. I am going to skip this for a second just so I can demonstrate a few of the other elements in here for fine-tuning. And one of the crucial ones is, of course, your datasets. So in here, you can upload from a cloud storage or an existing file, or in cloud storage, whether it's something that you have in a Google store bucket or storage bucket, or just upload it from your computer here, right? And this has to be in JSON-L, which is the recommended, data set. And you can even view sample data sets, if you will. And in this case, they have tons and tons of them, whether it's in JSON-L file, just like you're seeing here. I just randomly click on an evaluation example, and you can edit metadata and so on. Of course, you can do this with your own datasets as well. So let me close that back. And of course, you can also enable model validation and upload the validation dataset as well, right? So if of course, I don't have any datasets right now. So I'm going to download a sample dataset. It's called SF Train Data Flow. So let me actually go and upload that. So the next step is actually to get that dataset to a bucket for then, of course, Vertex be able to access. So I'm going to do that. I have 2 buckets already in here selected, and then I can start tuning, right? And you see that I have now a tuning job called Omar Fine-Tune Model 1 based on Gemini 1.5. The method is supervised and it's pending right now, and it's going to take a little while for it to instantiate. So while that is running, let me actually take you to another section here around model development, right? And this is whenever you're training a model from scratch. So if you click on train new model, you can take advantage of AutoML or even a custom, a little bit more advanced training environment. You have to be very familiarized with machine learning and data science concepts like hyperparameter counts and many others in here. So I am going to skip this one just because we're going to be focusing on how to deploy different generative AI applications using foundation models within the environment in here, or fine-tuning, right? So if I go back to the fine-tuning, now it is running. I can click on it, and you see that there's a fine-tuning metrics that are being generated, and it will appear there whenever they're ready. Now, this, of course, will also cost a little bit of money, right? So be aware of that. But again, this is yet another platform that you can use generative AI models, create models from scratch, extremely powerful for fine-tuning, allow you to automate a lot of the machine learning operations or MLOps operations within this environment as well. You can also get access to different embedding models, use retrieval augmented generation type of environment. So you deploy vector databases and so on. And of course, it will interact with the rest of the Google Cloud infrastructure for you to have different VMs, containers, and so on. So very, very powerful environment here in Google Vertex AI. Let's go over Microsoft Azure AI Foundry. This was formerly known as AI Studio, and Microsoft, keeps changing the name. I think that already has changed the name twice or 3 times. But it's another unified cloud-based platform that is designed to help you develop, build, and customize different AI-based applications, right? So you can go over many different third-party models and deploy these. And of course, at the time of recording, I already had an inference endpoint already deployed. And don't worry, because I'm actually going to be deleting these after recording, but it includes the reference endpoint. So it actually automatically creates a URI for you. And then you have the ability to interact with OpenAI's models, as well as actually interacting with many, many other models, hundreds of them within their model catalog. Many of them that are in Hugging Face, that are open source, other ones that are proprietary, like the O1 models or the O models from OpenAI, the smaller models for like chat completions from Microsoft, including Phi, which is very portable, very powerful for being small models and very cost effective, that you can also run in Ollama, right? So if we were covering Ollama earlier in the course, you can absolutely run some of these models locally without the need of investing into a very comprehensive GPU infrastructure, or for that matter, any type of ASICs as well. So, this allows you to with, to deploy these models with a couple of clicks. And there are over 1,800 models as of the time of recording, and this is actually continues to increase. You can have access to different playgrounds. So in other words, basically have a playground where you can experiment and iterate with different models and then customize them and customize a lot of your AI application components, including your system prompts and so on. And they have already a few previews of assistants, image playgrounds, real-time even audio playgrounds, some for healthcare and so on. So if I click on any of these, so let's say try speech playground, you have access to real-time transcription, back transcriptions, speech translation, and many others, right? So you can start interacting with many different models and, of course, different capabilities in here. So if I go back to the playground, the other cool thing about Azure AI Foundry is that it combines tools for data preparation, model fine-tuning, model testing, deployment, and monitoring in all this single platform. So for example, you can select from any of the predetermined models in here. I'm going to randomly select 5.3 4K for this section or for this demo. And you can select from a method for fine-tuning, whether it's a serverless API, so it allows you to fine-tune the model on a fully managed service that doesn't require for you to host or manage the infrastructure, or have a VM. So in other words, manage compute. So I'm going to do manage compute for this example. And this allows you to customize the model with your own training data set, right? I can change this to Omar 23 or Omar model 23. At the end of the day, this project is called Demo Project 23. You can add a description. You can actually add specific tags and values, and this is something that I extremely recommend for you to organize and have a good asset inventory within your environment. But you can select the machine size, right? It gives you the cost per hour, so you can go as big as 96 core with 900 gigs of RAM and a whole bunch of storage in there, or just something very simple like the one that I'm selecting. You can select the training data, the validation data, task parameters, very similar to what you saw with the other platforms like Google, Vertex AI, and in AWS. Another cool feature from Microsoft here is the prompt flow feature, which is a development tool that is designed to streamline the entire development of the AI application by providing you a way to prototype and experiment and iterate your application with different types of course, prompts, and system prompts and so on. And it has an evaluation flow, a standard flow, and so on. Many different examples from a gallery here, right? So if you want to do just a Q&A with your data, you can actually clone this example, and add it to your environment for you to actually create a new prompt, right? You can click on view details on any of these, and actually will tell you what are those examples of prompt flows implementations for you to then use, in this case, a chatbot interacting with your own data in a retrieval augmented generation implementation. Another powerful tool is tracing, which basically allows you to get an in-depth understanding of the execution process of your generative AI application. Basically provides a view of the execution flow of your application, and is really, really good for debugging your application and the complex implementations that you may have within your environment. So these are different environment features or different tools that I strongly recommend for you to become familiar with, and I play as you experiment with your implementations. It actually allows you to visualize your quote-unquote traces, right? You can use tools that are built in here that to trace your application within the Azure AI Inference SDK, using that SDK to get more visibility into your applications, right? So this is another element that is really good for you to become familiar with. Another one is the evaluation of your AI application, right? So if you create a new evaluation, you of course you have to deploy a specific model. Let me actually close that in there. And I already had a deployment. It was GPT-4o Mini, that I did a while back in here. But you can see that you can do a lot of different tests for your applications, and including generating some content and including the automatic evaluation using AI to measure how well your model and your implementation is producing good responses and so on. They also have ability for you to do monitoring and guardrails, to implement guardrails on content filters and block lists that you can implement within the environment as well. So if you want to create a specific block list related to a custom policy that is pertinent to you or to your organization, you can absolutely do that in here as well. Another thing that I want to highlight is that Azure AI Foundry has a section here called Code, and these are example templates and tutorials for coding AI within your environment, right? So coding your AI application. And they even have examples of knowledge retrievals of RAG, right? And you can even open these in GitHub. So I'm going to open it in a different tab in here. Or you can also see tutorials that they have related to each of the elements of not only these templates and these examples, but also across all Azure AI Foundry. So they have a really good documentation and a lot of tutorials and sample code in GitHub, just like you see in here. This is a test application called Contoso Chat, and it's a retail RAG copilot that is being used or that is deployed with Azure AI Studio and PromptAI. They still have their old name here, AI Studio instead of Foundry, but you get the point. Same thing here. And this is basically the application, the fictitious application that they have in here with basically a copilot or an assistant using retrieval augmented generation. So as you can see, these environments can accelerate your experimentation and your deployments of AI applications very, very, very fast, building on top of cloud platforms like Azure AI Foundry. And of course, we already cover the platforms in AWS and Google Cloud. In the next section, we're going to discuss a few things around cost management and security. Cloud-based AI platforms like the ones that we just discussed, Azure AI Foundry, which is what you're seeing in front of your screen, Google Vertex AI, AWS Bedrock, SageMaker, definitely they have become essential tools for you to leverage AI at scale. However, managing cost and ensuring robust security are two critical challenges whenever you're using these platforms. So here, what I would like to do is explore a few tips around cost management strategies and also security best practices for these leading AI cloud environments, and then to help you, of course, optimize your investment and, of course, protect your wallet a little bit, right? So I was making the joke that from the moment that you start experimenting in here and you start clicking on a few things, new machines are being instantiated, new S3 buckets in the case of Azure or AWS rather, or compute nodes or endpoints are being instantiated, and then in some cases you may leave them running. So you have to be paying attention to that. However, many of these platforms, including Azure AI Foundry, they provide a very comprehensive set of tools for cost monitoring and optimization. The challenge is that there are a lot of tools that people don't know about, right? But you have things like the cost planning, and as a matter of fact, they have a really good calculator So an Azure pricing calculator to estimate cost before you actually even deploy things, right? So Azure AI Foundry is definitely composed of multiple Azure services. So again, compute, storage, and many other ones. So it's important to account for all the components whenever you're planning these budgets, right? And then you also have quotas. So you can configure specific quotas within the environment to then prevent being able to get overcharged for things that perhaps you're not even running or using, but they're running rather. So you're not using them, but they're actually, you kept them running within their environment. All the AI models that are deployed by the Azure Marketplace or the model gardening Google and so on, they operate on a pay-as-you-go basis. So that allows you to a little bit more granular monitoring of consumption and then for you to analyze the associated cost. So again, Vertex AI also offers very flexible billing options, detailed to cost tracking, granular billing, labels for cost attribution, so you can assign labels to custom jobs or pipelines, which then they can be used to group the cost in billing reports, right? So again, if you are part of an enterprise, these are things, best practices that perhaps you're already following. But if you're getting started with some of these platforms, you have to pay attention to all these real-time cost control and optimization tools that are at your disposal. Now let's shift gears into security. There is a website that I helped create called aisecurity.cisco.com, which will redirect you to many different fundamentals, white papers, and guidance around security, including how to secure vector databases in the case of a retrieval augmented generation environment, what are AI security vulnerabilities, and the one that I want to highlight bring your attention to is the AI training environment security. And this is a paper that I co-author. Actually, matter of fact, most of these are actually have the honor to co-author with other colleagues. But this one specifically goes over the security best practice and considerations in cloud-based platforms, and specifically in the three that we have been covering here. So if I shift your attention to the paper and specifically to this section here, we have a section related to the cloud data protection recommendations, and of course, very basic but very important best practices like using multi-factor authentication everywhere, log API user activity, protecting your data, using, of course, secure communications for your cloud resources, and in many cases, actually using strong crypto implementations. However, we also have linked different guidance documents from Bedrock, SageMaker, Google Vertex, and also from Foundry later in here. But I already have this open in different tabs for your reference. I'm not going to go and read this for you, but I strongly recommend for you to become familiarized with these security best practices. And as a matter of fact, just generic best practices for the cloud. And in some cases, you can even use Amazon Q to learn about the different security best practices within the environment as well. So leveraging the power of AI in some of these platforms, right? They also have examples on how to protect your data in Amazon SageMaker, and also Google Cloud has a lot of security controls for generative AI, and they even have a section here that basically compares all the different functionalities and the different controls available for generative AI features across their ecosystem. So definitely I recommend for you to read these security best practices, and specifically since these platforms, all of the ones that I mentioned, Vertex, SageMaker, AWS Bedrock, and AI Foundry from Microsoft, they are changing by the minute. There are new features that perhaps are introducing new security challenges, and then they also introduce new security best practices and configurations that you should pay attention to on an ongoing basis. You can also deploy Olama in the cloud, like in AWS, in Google Cloud, and so on. You can use things like Terraform to automate that deployment. But you may ask, why would you like to run Olama in the cloud if you can run it in a laptop or if you can run it in a PC with a good GPU? Well, in some cases, you may not have enough compute to run some specific models. Let's say a large parameter count model, let's say something that is running 80 billion parameters or 128 billion parameters and so on, right? So those, you may not have the compute time or the compute power in your home lab. So in that case, you may deploy it in your private instance, let's say an EC2 instance in AWS, and then run that from there. However, whenever you're learning, it is a good thing that you can incorporate these proven technologies like Terraform and so on, and then deploy things like Olama with a specific model, and then going over and run other tools on top of it, like Open Web UI, which we covered earlier in the course. So I have a write-up about that. I'm not going to go into a lot of details because the write-up actually goes over the specifics, but this is a repository that includes a lot of different Terraform scripts and all your configuration variables and so on for you to deploy the the architecture of running Olama and Open Web UI in the cloud. So the deployment architecture looks like this, and this is actually in the GitHub repository that I have linked in there, where you have different EC2 instances, a private and a public subnet, and then you have the ability to run Open Web UI in an ECS Fargate implementation. And then, of course, you can take advantage of Route 53 for domain tasks or DNS tasks and so on. Now, what I did in here is actually I provided the different elements of the Terraform scripts, including the LLM models, the config variables, the Open Web UI settings, which is a separate section within that GitHub repository, and then of course all the custom domains and any type of SSL certificates that you may need for securing the API gateway, and including the application load balancer that is instantiated for this environment, and specifically for Open Web UI. And then to initialize the Terraform platform, it is a typical Terraform init, and then Terraform apply into that. And I just noticed that I have a little typo in there because it's supposed to be another line in there. But at any rate, all this is in the repository, and I would like to actually at least share this with you because there are many different ways that you can deploy your lab, whether it's on premise or in the cloud or in a hybrid mode as well.